Welcome, everyone, to our Intro to Data Structures webinar. If you don't already know, we are Long Beach Women in Tech. We are a community in Long Beach for women, non-binary individuals, and allies. And we host fun social events as well as career development workshops similar to these every month. So currently we use Eventbrite to publish our events, so feel free to check that out for future events. Today we are going to have Amelia be presenting a little bit about linked lists, stacks, and queues, things that you've probably heard in interviews and such. She is also going to have an intro to each of these data structures as well as real live code. And that will be written in Python 3. Don't worry about writing anything down. We will have the code examples available in GitHub after the presentation. As well as Amelia, we will be writing a blog about some of the little gotchas with some of these data structures. So feel free to take it away, Amelia.
Yay. With like the little gotchas, this is going to be like the basic data structures. I didn't want to scare anyone away. So the blog is more like, we're going to dive a little deeper into that. I also talk with my hands. You guys can't see me. So if you guys are like, I think she's talking with her hands, I have no idea what's happening, just yell at me and let me know. The online thing is throwing me for a loop a little bit. All right. So can everyone see the PowerPoint?
Yes.
Okay, cool. And then I have my little PowerPoint laser pointer here. All right, so intro to data structures, linked lists, stacks, and queues. So first, what is a data structure? Data structures are the way we store, organize, and retrieve data. So here's 3 questions. I'm not going to give you the answers now. If I've done this correctly, you guys should know these answers by the end of the talk. So what data structure would you use for an undo mechanism in a text editor? Also, what data structure would you use for an online quiz? And then what data structure would you use for a phone system in a call center? Not giving you the answers now at the very end, but something to think about as I'm going through. So why are data structures important? Why data structures are important. It's important to know all the data structures so you are able to manage data in an efficient way. You should know each data structure, how they input information. So how is the data received? Will it be added to the beginning, end, or middle? Does an existing point of data need to be updated? How does the data structure process information? How data is manipulated? How does existing data that has been stored need to change to accommodate new, updated, or removed data? How does the data structure maintain information? How is the data organized? What relationship needs to be maintained between the data? How much memory must the system allocate to accommodate the data? And also, how do you retrieve this information from the data structure? How to find and return data? How do we access the information again? What steps does the data structure need to take to get the information back to us? So we're going to start off with nodes. Nodes are the basic data structure which contains data and one or more links to other nodes. Nodes can be used to represent other data structures. In these data structures, it is possible to traverse from one node to another node. We'll be using nodes in all the data structures I'm going to go over today. A node is a data structure that stores a value that can be of any data type and has a pointer to another node. So the implementation of a node class should have at the very least the methods to get the value that is stored in the node, to get the next node, set a link or pointer to the next node. And here's our node class. So over here, I just want to show you that this is a data structure we're not going to be going over today, but you should know that here's a node and you've got a pointer to 1 and a pointer to 6. So it doesn't always have to be, here's a node, it has one pointer to another node, another pointer to null or another node. It can have multiple. And like I said before, in your node class, you've got your value, next node, then you can set next node, get next node, or get the value of your node. And we're just going to play with this data structure just a little bit. So if you want to create a node from this class, we're going to call it first node. And just one lonely little node. Here's your value of 1. Its pointer, it's pointing to null. And keep in mind that this pointer is part of this node. It's not outside of this node. It has the value and a pointer. So let's create 2 more nodes, second node and third node. So these are all pretty basic nodes, not really pointing to anything. So let's make the next node, let's make 1 pointing to hello. How we'll do that is first node, which is 1, dot set next node, and we're going to pass through the second node. So up here, we'll take self, which is 1, the first node, next node equals the next node, the value that we passed in. So that will look like this. Null is supposed to be here. The second node is still pointing to null. I just didn't write that in. So now let's add, for the second node, we want the second node's next node to be third node. So we'll do the same thing we did before. Second node dot set next node, passing in the third node. So there you have, when you're like, well, what's the next node of 1? It's pointing to hello. What's the next node of hello? Pointing to the third node. And what's the next? Pointing to null, nothing. Questions? Did I lose anyone yet? I'm guessing no. Yeah.
Wait, let's take a few seconds.
Okay. Don't be scared, guys.
I'm personally not a very fast typer.
That's okay. And you guys don't have to be typing. You can just sit back and watch and then go on GitHub later.
Thing to present right now?
What?
What are you programming in and what are you using to present?
Oh, I'm using PowerPoint and it's Python 3 is what the classes are in.
Okay, thank you.
Yeah.
Hi. If you don't have any problem, can you go to the previous slide? I just want to look at it again.
Oh, yeah.
Thank you so much. That's it.
Yeah, sure.
Udal asks, is this the same concept using Node.js?
So the concepts for data structures are the same, but it might look different in the other languages. Does that make sense? Like it might be written differently. I know this is not how you create a class in Java. At least I don't know Java, so I don't think so. But yeah, okay, cool. It's pretty similar to Node. Awesome. Yeah. But if any of you guys have that green book, Cracking the Coding Interview, it's in Java And like I said, I don't know Java, but you can follow along. You understand what it's doing. And you can do the same things in other languages.
Okay, can you go on, Amelia?
Yeah.
We'll keep an eye on the chat.
Okay,
if anyone thinks of anything else.
Thank you. All right, so linked lists. Linked lists are linear data structures where elements, nodes, are linked using pointers. In a singly linked list, data is stored in nodes and each node is linked to the next. Each node in a linked list consists of the following parts: data, and a pointer, which is reference to the next node, and head node. So the head node is the first node in a linked list. And if the list is empty, then the head node is null. So this is the head node. And if it was empty, it would just say head pointing to null. Here is our linked list class. So we want to create a linked list. And I'm going to start the linked list with the string hi. So it is now the head node. When you first create a linked list, self.head node is node. See how it creates a node? Hi is the node. It's pointer pointing to null because we haven't added anything else in yet. So let's say we want to add 33 into our linked list. So what we're going to do, we're going to do new list dot insert at the beginning. Go up here. That creates a new node with the value that we pass in. And we're going to point the new node to the head node. So 33, its next pointer, next node is hi. We're not done yet because 33 has now become the head node and we have to point the head to 33. So now our linked list is 33 pointing to hi, pointing to null. Let's add in 44. Again, creates a node. It's not pointing to anything because right now it's just a node. So we are going to point that node to the head node. So now 44, its next node is 33, but it needs to be the head. So we're going to point the head to 44. So this is our linked list. It was 44. What's the next node in 44? 33. What's the next? Hi. What's the next? Null. So let's say we want to remove node 33 right in the middle. So what we're going to do is we're going to set our current node to the beginning of our list, which is the head node. So right now we are on 44. So does our current node, is it the value that we want to remove? No, it is not. So what we're going to do, we have to look at the next node. So we have to look at current node's next node and compare it. Is this the value that we want to remove? Yes. So what we're going to do is we're going to take 44's pointer of next node and point it to 33's next node. And that will remove 33. So now our list is 44, hi, and then null. Questions? I know when you start removing things, people can get frustrated or flustered.
Perfect. Do you mind looking at going back to the other slide too, so we can have a moment to look at it?
Yeah, no worries.
Thank you.
So what might be an example of something we'd use this for?
So there's multiple things that you can use this for. You can use the linked list, like this, kind of in another data structure if you want to. There's also, the only example I can think of is the example I gave at the beginning, but I don't want to give it up.
I mean, that's fair.
Actually, Michelle came up with a really good example the other day. She said, like, let's say you're making a necklace and you're linking beads together. So that's kind of an example, a visual example if you want to do that. I thought that was a good one. I'd never heard that before. I liked it.
Yeah, a real world example. There's also reasons to use this data structure from a performance perspective as well. And that's probably something we will talk about in the blog.
Yeah, I dive a little bit deeper.
Does anyone in the chat, can anyone in the chat think of a real world example where they might personally find this useful?
There's length of a line of people.
Mm-hmm.
Amelia?
Ready to start? On to the next?
Oh, wait, there was an example given, and it's length of a line of people. Is that an appropriate use case for this data structure? And list of employees.
Yeah, you could do that. You're going to see one of the data structures is very similar to this that we're going to go over. It kind of uses this. And a list of employees, yes.
What would that look like, Amelia?
So instead of 44 or high, you could have Amelia and then Nicole. Because what's nice about nodes, it'll take in strings, integers.
I don't know if it helps, but when I think of linked lists, I think of things where I have to do things in iteration because of the way linked lists work. You kind of have to go to each node to find what you're looking for. So maybe like a good example would be like a tutorial where you have like step 1, step 2.
Right. Or like a scavenger hunt.
Yeah, exactly.
Yeah.
Okay, thank you, Amelia.
Yeah. All right, so our next data structure is stacks. So stack is a data structure that follows last in, first out. That means the last node added to a stack is the first node to be removed. So think of a stack of dirty plates. You're not going to go and say, I'm going to clean the very bottom plate first. That's ridiculous. So you're going to clean the stack that you are physically looking at, and that's the one you're going to take off first. It's also the first one you put on. So the main methods of a stack data structure: push, add a node to the top of the stack; pop, removes a node from the top of the stack; and then peek returns the value of the top without removing the stack. And then it also is empty is important. And that returns true if the queue is empty. So here's our stack. We got 5, 4, 3, and 2. So if I wanted to peek at this stack, what one would get returned to me? What value would get returned to me if I wanted to peek at that stack?
Would it be 5?
No.
Or wait, no, 2.
Yes, 2. That is also the node that we would pop off. So 2 is gone. So the next one that we would peek or pop would be 3. Again, like I said, think of it like a stack of dishes. You're looking down on it. So all you see is that one dirty plate. That's all you can look at, and it's all you can take off. And then 5. And then here's the class stack. I know it's a lot. But like we've been saying, it's going to be in GitHub so you guys can really look at this and play around with it. I always suggest trying to break code because that actually teaches you a lot. So let's say we want to make a plate stack. So over here is where we're going to create our stack. And see, there's nothing in our stack. If you see, I didn't pass anything in there. I'm just creating a stack. So the top item is none. Size is 0. So if we wanted to see if this is empty, it'll say true. It's empty. So let's say we want to push one plate onto here. What do we have to do? We have to make that a node. So the value that we sent in becomes a node. We haven't done anything with it yet, so it's pointing to null. So we're going to set the new node's next node to that top item in the stack. So now this next node is top item, but the top item is now a 1. So we've got to move the top item to 1. There we go. So that is now our stack. Top item is 1. So next is null. Let's add 2. So it creates a node with the value that we've passed in, which is 2. It's just a node, not pointing to anything yet. So let's set it to, so let's set our next node for 2 to be 1. Still not done yet, because 2 obviously is the top item, but top item is still pointing to 1. So we've got to change that to the top item. Let's add one more, push one more. 3 creates a node out of the value we passed in. 3's next node needs to point to 2. It is now the top item of our stack. So the top item has to point to 3. So this is our stack. So we want to peek at this stack. What will be returned to us?
Three?
Yes. Awesome.
I have a question.
Mhm.
Oh, wow, there's a question in the Slack chat that I'd like to. So the peak just returns the value
Yes.
of the node to be popped.
Yes. If when you peek, it's just saying, oh, it's just 3. You did not do anything with this. All you said was, it's like you're looking at that dirty dish and you know what that dirty dish is, but you are not taking it off the stack. But if you do want to take it off the stack, that's what pop is for. So, and you don't have to put anything in here because it's always going to remove. Yes, push to add. Definitely. Push to add, pop to take off. I like to think of it as pop off. I know it's dumb, but it helps. So we're going to pop 3 off this stack. So first, we're going to see, is this empty? This is not an empty stack. So we're going to remove the top item. So what do we have to do to remove the top item? Well, it's not going to be the top item anymore. So top item is now pointing to 2. So now our stack, top item is 2, pointing to 1, pointing to no. Let's take one more off the stack. Is it empty? Nope. So top item is going to point to 1. And now we have a stack of just 1. Any questions? I figure I'll leave it on this page instead of going to the question page. So you guys can
I want to see your GIF and then come back.
This one's a fish.
Okay, yeah.
I love it.
Okay.
So Sandra in chat is asking, so push is to add?
Mm-hmm. Yes. Push would add something to the top of this stack. Any more questions or?
I have a kind of a non-tech world example too.
Okay. Well, I love the examples because these things are kind of hard to wrap your head around. So this is great.
It's kind of like with dirty clothes, you just throw it in the hamper. And then as you're putting it in the washing machine, you have to grab the ones at the top.
Right. Yeah.
All our examples are chore related.
I have one that is food related.
Okay, I want the food related.
Okay, yeah, that one's way more fun. So you have a stack of pizzas stacked on top of each other, right? You've got to go to the first one. You've got to take that off to get to the second one, and then take that off to get to the next one. You can't just grab the pizza in the middle or they're going to go everywhere. That's better than chore-related questions or examples.
Maybe in terms of a tech example, I'm thinking of a quiz that won't let you progress to the next question until you correctly answer the first question.
Yeah.
Yeah. Okay, I think we're ready.
Okay. All right. So Q, which is Nicole's favorite. So a Q data structure is composed of nodes which follow first in, first out, which is FIFO. So the first node in the queue is the first one to be removed. So think of you're at a checkout line and you're the first one in line. You're going to be the first one to be checked out, and then the second person, and then the third, and then the fourth. So it's different in terms of stack. It's considered a line. And I learned lines in the UK are actually called queues. So the main methods of a queue are enqueue, which adds a node to the back of the queue. Dequeue, which removes nodes at the front of the queue. Peek, which returns the value of the node at the front of the queue without removing it. And then is empty returns true if the queue is empty. So my example is, so you've got 5, right? So 5 is enqueued, which is added to the back of the queue. And then 4 is added to the back of the queue. 3 added to the back of the queue, and 2 is added to the back of the queue. So here's the back of the queue. Here is the front of the queue. So when we dequeue, 5 is going to go first, then 4, 3, and 2. And then here is our queue class. In my little example, we're going to pretend it's a deli line. So let's create our queue. The queue, if you've noticed, has a tail and a head. We are using both because we're adding to the tail and removing from the head. We have to keep track of both. So our deli line is null. It is empty. Let's add combo 1. So we're going to enqueue combo 1. We created a node. And we're going to check, is this queue empty? It is empty. Pretty easy when it's empty. All you do is the head and the tail become this node. So there's only one node in this queue. So let's add another queue. Let's add another node, which will be 2. So we go up here. We're going to create that node. It is 2. It's pointing to null. Is this empty? It is not empty. So then that's when we're going to set the tail. So this is the tail. So we're going to set its next node as the new node, and the new node becomes the tail. So this is the tail. Its next node is now 2, and now 2 is going to become the tail. So now we've got our queue, combo 1 pointing to 2, and 2 is pointing to null. Let's enqueue 3. 3 creates a node pointing to null. So we want to add it to our queue. So this is the tail. So now this next node will no longer be pointing to null. It's going to point to 3. We're not done yet. This has now become the tail. So now we have to set the tail to 3. So this is our queue. If we're going to peek at our queue, is it going to return the value of tail, or is it going to return the value of head? Which one came first?
Combo 1?
Yes. Awesome. So that also means it's the first one to get dequeued. So let's dequeue combo 1. So what we're going to do, deliline.dequeue. Is this empty? This is not an empty queue. If it's not empty, the item to be removed is the head. It's always going to be the head. So head is now going to point to 2. And now our queue is 2, 3. Any questions about this one? I know sometimes it can get a little wonky because you have to keep track of a tail and a head. But yeah, any questions? Anyone? Or can anyone think of really good examples of real life that you've seen this in, possibly?
I like that you called it deli line.
I know, right? Yeah. Besides the deli line.
Call center. I swear to God. Sometimes I don't believe they are respecting people.
Right?
Yeah, right?
Yeah. All right, I'm going to go to my question slide. All right. So are you guys ready to answer those 3 questions that I had at the beginning? Maybe, kind of, sort of? Okay.
Bring it.
Okay. What data structure would you use for an undo mechanism in a text editor? Someone's got to answer.
Yeah, either unmute yourself or put it in the chat.
All right, I think Sandy got it. Yes. Yay. I wish I had prizes to give out.
I know, right?
Next time, you guys, I'm going to have something to give out. All right, staff. Yay. Next one. What data structure would you use for an online quiz?
Is it a queue?
It is not.
It is not.
You could use a queue for this. I don't want to say queues, but there's a better one for queue.
I think Tanya Gupta got this one.
Yeah.
The list.
Yeah. So another thing that this could be used for is your forward and back button when you're on the internet, because you can only go forward or back. We only talked about a singly linked list, but there are linked lists that have pointers to the previous node as well. So read the blog for that, because that is what I'm adding in the blog. All right, so the last one should be easy. What's left? What data structure would you use for a phone system in a call center?
No, it's not.
Yeah. Q was not wrong for this. Just, don't you love those questions? It's not wrong. This one's just better. I hate those questions. I'm sorry.
No, I think I just missed that linked list portion because my cat ate something that was bad for him. So.
That's okay. Cat excuses are totally okay.
A lot of my life.
That is it, everyone. I hope you enjoyed our basic linked list, stacks and queues. Like I said, I'm going to write a blog that goes a little deeper into this. There's a lot more you can do with these. We could be here forever talking about them, but I think you guys would be really mad at me if I did that. So, what's the GitHub? We're going to send that out soon.
I can post the Long Beach Women in Tech GitHub in general. And it is an open source project. So feel free, if you see a project in there or a project you'd like to start in there, go for it.
We'll be emailing it to all attendees once we have it uploaded.
I hope this helped. If you've seen I could refresh some things.
Yeah, this was really cool, Amelia. Thanks.
Yeah. Cool. Anybody have any more questions, or are you just like, it's Saturday? That was it.
Where can people learn more?
Our GitHub, like I said, a blog. I actually really like, if you guys are looking for interviewing, there is LeetCode, HackerRank, and I really like Interview Cake.
Oh, yeah, someone was just telling me about that.
Yeah, no, those are really, really good ones. And then also, I really like my Cracking the Coding interview book. That green book explains things too.
So hang on, you're telling me interviews are cake now too? I don't even know what to believe.
Yeah, I'm not gonna lie. When someone told me that, I was pretty excited just because of the cake part. Oh, thanks, Michelle. Thanks, guys.
Can you post your resources in the chat, Amelia?
Those are my resources.
I think Michelle and I covered.
Oh, okay. Perfect. Thank you.
Yeah.
I just saw that.
They're on top of it.
We have all the links in here.
Yay. Another thing, I did this after Code Camp. HackerRank actually has a pretty good YouTube, and they have, I can never say her name, but Gail, the woman who wrote the coding interview, they have her on video going over data structures, and that really helped me a lot. So I highly recommend that.
Thank you.
Yeah. And let me know if you guys need any help. I just did a coding camp. I came from healthcare. And if I'm unable to understand stuff, you guys can too. Yeah. I do not have a college degree. So yeah, just keep on studying. Never ever stop.
I know. What boot camp did you go to, Amelia?
Coding Dojo.
Coding Dojo.
Yeah, and they have a pretty good online one too. They had a really good. I didn't do the online one. I was one of those people. I had to get up and go and actually go to the place. But before coronavirus, they had a reputable online coding platform. So check it out if you want to.
Yeah, I have a bachelor's in studio art, and now I teach front-end web development. So just go for it.
Yes. Yeah, leak code is fun. Leak code can give you a headache, though.
Yeah, like some of the leak code problems, they're kind of hard, but like if anybody wants to post about them in like our Slack channel or anything, that's a great place to reach out to for help. And don't feel afraid to reach out for help on this stuff, because like that's a perfectly valid way to solve problems. Obviously, you can't do that like in an interview, or can you? In fact, a lot of the time, if you're in an interview and you say, "Hey, you know what? I'm not sure how to do this. Maybe, can I do this, or maybe can I get a hand with this?" You might be surprised. They might be more open to helping out than you think.
Mm-hmm.
The best advice I've gotten for coding interviews, they are not looking to see if you know how to solve the problem. They're looking to see how you solve a problem you don't know how to solve, if that makes sense.
Yep.
They want to see your thought process. And honestly, I think it was Michelle that told me this, or Owen, I can't remember who, but they want to see if they want to work with you. So if you don't know something and you ask them questions and you guys are just like figuring it out together, that might actually be better than you just knowing the answer right off the bat.
Mm-hmm.
Those are definitely some of my favorite interviews.
Yeah.
Yeah, we're all very open to helping. We've all been there. We've all been at a point when we're like, "Oh, I just want my first tech job.
Yeah.
Someone hire me."
So I'm a huge proponent of the Cracking the Code interview book. And there's one particular page in there that I recommend to everyone doing interviews. I just found the image of it online, and I'm posting in the chat. But I not only use this method for interviews, I use it in my day-to-day job as well. So I highly recommend working through this workflow, because it really does help you break down those whiteboard problems.
Ooh, great resource.
It also helped me a lot managing my frustration with leak code problems. As much as I love the challenge, sometimes they can be overwhelming. So this definitely helps a lot.
Thank you for sharing that, Michelle.
Yeah.
I have that diagram posted right next to my bed.
That's awesome.
I noticed it's really helped me articulate just general like ideas, and like I think that's why software engineering is so like useful. Just your life. So thanks for sharing that.
Yeah. I mean, I'm cool with just hanging out and answering any questions you might have. But in terms of the data structures, that's all we have for today. We will do more of these. We're currently working on the data structures series. Owen, he has his Swift series, and we're pushing out blog posts to offer resources. If you would like to contribute, feel free. We want to, Long Beach Women in Tech is to provide a platform for anyone to share their information. So if you want to write a blog post, if you want to do your own series and you want to collaborate with us, just contact us.
I highly recommend presenting. I am terrified of presenting and speaking in public, so this is a safe place to practice that. And it will help you get used to talking about tech. If that makes any sense. Coming from a non-tech background, that was really hard to do, is just talk the lingo. So yeah, I highly recommend coming up with a talk. You guys know way more than you think you do. So I'm sure anybody can give a talk.
And this is something that you could put on your resume. You're like, oh, what do I put on my resume? I only have non-tech work. Well, create that. No, don't wait for someone to give you permission to do tech work. You can do it right now and put it on your resume.
So I posted two more things that might help. Pramp and interviewing.io. Those are resources to practice mock interview. And Pramp, I know someone that has done it for interviews, and you basically just get matched up with a random person and they give you like feedback and stuff. Interviewing.io, you work with engineers at some of the top tech companies, and it can even lead to job offers. And what's cool about that is it's anonymous, so there's no bias in terms of like education background or that sort of stuff. I think that those two in particular would be super helpful because you don't know the person. Yeah. So like if you mess up, you're like, well, I don't know you, so bye. That's great. So I highly recommend either of those.
I love it.